Okay, in the previous sections, we learned if you give me a linear equation or separable equations, we know how to solve them. Okay, the purpose of this video is for giving problem 1, give you a differential equation and an initial condition. When this problem solution exists and unique. Okay, this important theorem answers such a question. Okay. Basically, in this theorem, they say if you give equation 1, that means you give me fxy, okay, and x0, y0. Okay. Then the theorem say if f is continuous, and so is a partial f partial y, that's another function of x and y. If both function continuous in some rectangle, okay, this rectangle say x here, x is between alpha and beta, okay, y here is between gamma and delta, okay, and this rectangle contain a point x0, y0. Okay. If both functions f and partial y continuous in such interval, then there must exist an interval, exist this one, okay, as x0 as center, then this length is h, this is another h, okay. So this interval is within the interval alpha and beta, okay. So there must exist the interval like this one, and in this interval the solution to the problem 1 exists and unique. In other words, this is what that face of x. This is our solution. The curve of that is like this. Okay. Okay. So if I give you a differential equation as in the form 1, the problem 1 there, then how do you find out where the solution exists and unique? In other words, we just need to find this interval, okay. First of all, in this interval, your f and partial y, they exist are continuous. And also this interval contain x0 as the center, so they contain this point, okay. Okay, now let's understand what this theorem means by look at this example, okay. Okay, in this example, we want to determine an interval such that the following problems solution exist and unique, okay. So here is our problem, okay, like this, which is just like a special case of equation 1. Now, what we can say about this equation? In fact, this equation is linear. You can check that this equation is linear, okay. How do we know where this equation solution exists and unique? So to figure that out, we just need to find out where f and partial y continuous, okay. So we just need to find out what is fxy and what is the partial y, okay. So we need to write this form as a form like this, okay. Therefore, first of all, let's simplify this. You got 16 minus x squared y prime, subtract 9xy on both sides, okay. Then we divide 16 minus x squared on both sides. We got this 6x squared divided by 16 minus x squared minus 9x over 16 minus x squared y, okay. So the right hand side is our fxy, okay. Okay, next let's find out what is the partial f respect to y, okay. my fxy is this whole thing. Okay. Now, partial f respect to y. That means whenever you see x, you treat it as a constant. Okay. Now, let's take the derivative respect to y on the first term. There's no y there, you treat x as a constant, you got 0. Okay. Then take derivative respect to the second term here, respect to y. Treat x as a constant, so give you 9x over 16 minus x squared. So give you minus 9x over 16 minus x squared. Okay. So this is our partial f with respect to y. Okay. Then our fxy, let me write again, which is 6x squared, 16 minus x squared, 9x, 16 minus x squared y. Okay. Okay, we want to know where this function and that function continues. Okay. So let's look at partial f with respect to y first. This function is fine, continuous everywhere except the x makes your denominator equal to 0, which is x equal to trouble spots. Is x equal to 4 and x equal to minus 4. Other than those 2 points, everything is fine. So partial f with respect to y is continuous for all the x and y except x equal to 4 and x equal to minus 4. Now let's look at the second function. The same thing. This function is fine except x equal to 4 and negative 4. Then make your denominator as 0. So is this term. For any y, this function is fine. Okay. So therefore, for all the y is fine. So we just look at the domain for x. Okay. So here is a minus 4. Say this is x. Here is a positive 4. Everything is fine here, everything fine there, everything fine except those 2 points. So the domain is equal to negative infinity to 4, union negative 4 to 4, then union 4 to positive infinity. Okay. Now, those 3 intervals are fine, but we're interested interval contain x naught there. So for our problem, we're interested on our x naught is a minus 6 here. So minus 6 is here. Therefore, the interval we're looking for is minus infinity to 4. Okay, then we'll answer the question. In this interval, as long as your your x in this interval, minus infinity and 4, and minus 4, sorry. Minus 4 here, sorry. Negative infinity to minus 4, okay. Minus 4 to 4, 4 to infinity. As long as your your x in this minus infinity and minus 4, then your f, our f and the partial f, our f here, and the partial f, partial y will be continuous. Okay. Therefore, solution of this problem exists and unique. Now, let's look at another example. This example is like this. We want to solve y prime equal to y to the 1/3 and y0 equal to 0. Okay. So for this problem, x naught is 0, y naught is 0. Okay, what we can say about this equation? Is this linear? In fact, it is not linear. However, this equation is separable, so we can solve it. Okay. Now, in this video, we're interested to know, does this equation with this initial condition has a solution, and that only has one solution and only one? Okay, let's figure that out. Okay. So since this equation is separable, we know how to solve it. Okay, so you have like a dy dx equal to y to the 1/3. So we can separate variables. Okay, so you got y to the negative 1/3 dy equal to dx. Okay. So then we can integrate on both sides. Okay. Now we integrate the left-hand side, gave us 3/2 y 2/3. And the right-hand side, integrate, you got x plus c. Okay. You can say, why you don't have c on the left-hand side? That's fine. You put 2c together, put on the right-hand side, combine, give another c. Okay. So if you have a problem to say, for the integration for this one, I suggest you remember this one. Okay, we use this equation all the times. If you know this one, let's solve you most of the problem for the integration. Okay. In the differential equation class, we need to know how to integrate things. That's the basic things. Okay. Now, by using initial condition here, that means 1x equal to 0, y must be 0. Okay, so let x equal to 0, you got this. 1x equal to 0, y is 0, so like this. Then the c must be 0. Okay, so our solution is like 3/2 y 2/3 equal to x. Okay. Now let's simplify this a little bit. We got y 2/3 equal to 2/3 x. Okay. Next, we do this. Then we got y squared equal to 2/3 x whole things to the third power. Okay. Now, then we take square roots on both sides. Then we got a positive and negative square roots 2/3 x whole things to the third. That means we got a positive and negative 2/3 x to the 3/2. Okay. So what that means? That means we have two solutions. One is y equal to positive 2/3 x to the 3/2. Another is y equal to negative 2/3 x to the 3/2. Okay. So the cause of this problem is two. First of all, this equation is not linear. We call this equation nonlinear. Now, why we have more than one solution? The condition of the theorem must not be satisfied. Okay. Now let's look at this. So for this problem, fxy equal to y to the 1/3. Okay, and the partial f respect to y give you 1/3 x y to the negative 1/3, negative 2/3. Okay. So remember our y0 is 0. We're interested at x not is 0, y not is 0. Okay. So obviously this one y equal to 0. This is not defined. So of course it's not continuous. So that's why we may get more than one solution.